This is Advanced Math 1.6 notes. That's Unit 1, Lesson 6. The title's Rational Expressions with Negative Exponents. We are going to simplify number 1. A raised to the negative fourth minus B raised to the negative second. All right. First off, remember back to Math 1, maybe even middle school math, when you learned about negative exponents. Negative exponents move to the denominator. I'm hoping you guys all remember that. Negative exponents move to the denominator. So this here, what I'm about to show you, is a common mistake kids make. They'll say, oh, since it moves to the denominator, negative exponents move to the denominator, they make one big fraction like this. And that is wrong. It's wrong. Please do not make that mistake. Why is it wrong? I mean, if it was like this, a to the negative fourth times b to the negative 2, that would work. That would move to the denominator all in one swoop, and that would be perfectly fine. So if that one's hunky-dory and nice and good and everything's fine, why is this one wrong? If it's multiplication, you can move it together all as one because this is one big term. It's one big term. There's two factors, but it's one term. Here there are two separate terms. If there are two separate terms, meaning it's held together with a minus or plus sign, you cannot make it into one fraction. If there's two or more terms, you have to make it into individual fractions. So that means it would look like this. 1 over a to the fourth minus 1 over b squared, two separate fractions. Do you see that? Two separate fractions. All right, it's asking us to simplify, so we're going to add fractions. And remember, in order to add fractions, we need to have a common denominator. And my common denominator here is a to the fourth b squared, because I don't have anything in common. My first one's missing a b squared, and my second one's missing an a to the fourth. B squared times 1 is b squared. You guys probably haven't heard a bell in a while. B squared times a to the fourth is a to the fourth b squared. 1 times a to the fourth is a to the fourth. B squared times a to the fourth is right here, b squared a to the fourth. And sorry, there's a minus sign right in there. So that's b squared minus a to the fourth. And I can factor b plus a squared and b minus a squared. And why is that? Because b times b is b squared, a squared times a squared, I'm going to say that again, b times b is b squared, a squared times a squared is a to the fourth, plus minus, because it's a difference of two squares, all over a to the fourth times b squared. Looks like that. Now, here is the deal. Because nothing reduces, do you see that? Nothing reduces at all. If a person had left it like this, b squared minus a to the fourth over a to the fourth b squared, that would be perfectly fine. Both of these answers are correct. I'd like you to write it this way just to get used to factoring, because you always want to factor to see if you can reduce. But no, if you were taking a test and you got this and you only see this as a possible answer, kids freak out like, oh no, this is wrong. This is wrong, Mrs. Torres, because the person didn't factor. You only have to factor when simplifying if factoring allows you to reduce. Nowhere up here did it say factor. We only factor, 1, if it tells us to factor, and 2, if factoring allows us to reduce. So since it didn't say factor and factoring did not allow us to reduce, that is our final answer. Or this, if you choose to factor, that's totally your choice. I cannot reduce here because this is multiplication and that's subtraction. I cannot break up itty-bitty terms. It doesn't work that way. Okay, number 2. C to the negative 2 minus d to the negative 2 all over c to the negative 1 plus d to the negative 1. Now you can see I have multiple terms. In the numerator, I have 2 terms. In the denominator, I have 2 terms. So I cannot willy-nilly move things up and down. I cannot just like bring these 2 to the bottom and these 2 to the top. It does not work that way. What I have to do is make 4 individual fractions, like so. And then 1 over c to the first plus 1 over d to the first. And now it looks like a complex fraction, just like what we were seeing in a previous lesson. We clear a complex fraction by multiplying everything by common denominator. And my common denominator is c squared d squared. And I just like to make it a fraction. C squared d squared. C squared, everything, top and bottom, because I'm clearing a complex fraction. What I multiplied at the top, I have to multiply to the bottom, and I just distribute it to everything. Okay, here c squared is gone completely, leaving behind a d squared, minus d squared is gone completely, leaving behind a c squared, all over 1c is gone, leaving behind a cd squared, minus 1d is gone, leaving behind a c squared d. All right, now don't say, oh, I'm not going to factor because it's not going to reduce. We don't know that until we factor. That's why I'm saying just factor because we're used to it and we should, but it may not reduce. We're hoping it does. Okay, d plus c and d minus c because it's difference of two squares. And then here there's a GCF. They both have a c in common. They both have 1d in common. Excuse me, cd times d is d squared, minus cd times c is the c squared d. I'll repeat that. cd times d is the cd squared. cd times c is a c squared d. And then we reduce. And it does reduce here. And they're not opposites. They're exactly the same. D minus c and d minus c is d plus c over cd. And I'm going to double check because I think I messed up one of my signs, and I did. I'm not going to start over because it's an easy fix. Plus, plus, and I got sloppy, and that is a minus. So it is going to change what I reduce over here. So if you caught that, my apologies. Plus, plus, that should have been a plus. So right here should have been a plus. So I'm just going to change that one to a plus and that one to a minus so I don't have to erase my ink. Okay, so it factored still, d plus c, d minus c, and the d plus c and the d plus c reduce, not the d minus c's like I originally had, and all is good. So what's left behind is a d minus c over a cd. And that there is the answer. All right, number 3. 2x parentheses x minus 2 raised to the negative 1 minus x squared parentheses x minus 2 raised to the negative 2, and we are going to simplify. Okay, I have two terms again, so I cannot just make one big fraction. I have to make two individual fractions. This fraction minus that fraction. Now this fraction, this is the only piece negative, which means the 2x is staying. And x minus 2 is moving to the bottom with now a positive 1 exponent. Okay, second term, this is the only thing negative, so x squared is staying, and moving to the bottom is x minus 2 to the positive second power. All right, I need a common denominator. And the common denominator is going to be x minus 2 squared because they both have 1 in common, but I always take the larger one. X minus 2 squared is the common denominator, which means I'm going to multiply this guy right here by the x minus 2 top and bottom to give me the x minus 2 squared at the top. And then I distribute because I'm going to want to combine like terms. That is 2x squared minus 4x. And then here, it already has an x squared, so really you're just multiplying by 1 top and bottom. It's not really necessary to show that, but I'm not multiplying by anything because it already has the common denominator. So minus the x squared. Combine your like terms. That gives me x squared minus 4x all over x minus 2 quantity squared. Let's see if factoring allows me to reduce. X times x minus 4 over x minus 2 squared. It does not, nothing here reduces. It's still a good answer, but this here would have worked as well. You do not have to write both. I'm just again showing you that factoring is necessary if it allows you to reduce. If it does not allow you to reduce, then this previous answer is okay. So either one. I like this because I know you're always trying to factor to see if you can reduce. Because like up here, if I stopped here, it'd be wrong because factoring did allow me to reduce. So this would be wrong and not okay. Where down here, it is okay to not factor because factoring did not allow me to reduce. So just factor and be safe. All right, last one. Number 4. A to the negative 2 plus b to the negative 1 times a to the negative 2 minus b to the negative 1. This one, there's one big term because it's held together with multiplication, but inside that I have 2 terms, and inside there I have 2 terms, and both of those 2 terms and both of those 2 terms have negative exponents. So I'm going to treat them individually on the inside. 1 over a squared plus 1 over b, and then 1 over a squared minus 1 over b. Okay, now I'm going to simplify them individually. In there I'm going to find a common denominator, make it 1 fraction, and in here I'm going to find a common denominator, make it 1 fraction, so that I'm able to multiply the 2 fractions, simplify, reduce. Okay, first fraction, my common denominator looks like it's going to be a squared b. Second fraction, it looks like it's also going to be a squared b. Okay, first fraction, a squared's already taken care of, so I multiply by 1. And I'm sorry, it's not, I need a b. And b times 1 is b. Here I multiply by a squared, and that gives me plus a squared. Okay, I multiply by b because b times a squared gives me the common denominator. B times 1 is b. b times a squared again gives me the common denominator, and 1 times a squared is a squared. Okay, here I multiply by b. b times 1 is b. b times a squared is my common denominator. Minus, I multiply by a squared. a squared times 1 is a squared. a squared times b is my common denominator. All right. I am ready to now multiply, and I don't need like terms. I don't need like terms or like denominators to multiply. So a squared times a is a to the 4th. b times b is b squared. And the top I'm going to leave like this, b plus a squared, b minus a squared, because it's multiplication. b plus a squared, b minus a squared. There's nothing that reduces. If you wanted to double distribute that, you could. It's not necessary. That's it. Nothing reduces. There's nothing else I can do. This here is my final answer. And that is it for this lesson.